In this video, we're going to talk about mean absolute deviation. We're going to start off with a definition, and then we'll look at the steps on how to find it. So the mean absolute deviation is a way to measure the variation within a data set. It's going to represent the average distance between each data point and the mean. There's three main steps that we're going to look at to find mean absolute deviation. We can abbreviate MAD. The first thing that you're going to do is just find the mean. So we know from before that if you're going to find the mean, you're going to add up all of your data values, and then you're going to divide by the number of data values that you added up. So main operations, adding, and then division. The second step, once you have your mean, you're going to find the distance between each data value and your mean. The operation that you're going to be using for that is just subtraction. And then once you have found your new numbers, you're then going to find the mean again. So you're going to take all of the numbers from step 2, find the mean. So you're going to be doing the exact same thing that you did in step 1, which is adding and then dividing. You're just going to be using your new set of numbers. So we're going to work through an example where we find two different mean absolute deviations, and then we're going to go ahead and compare those together. So we have a table that's representing the prices of the 5 most expensive and the 5 least expensive dishes on a menu. Again, mean absolute deviation is going to be the average distance between each data value and the mean. Let's start with the 5 most expensive dishes. So we saw from before that the very first thing that we're going to do is find the mean. And for this one, we have 5 numbers that we're going to add up. So 28 plus 30 plus 28 plus 39 plus 25. And then after we add those up, we're going to divide by 5 since there are 5 data values. So when we add up all of the numbers in the numerator, that's going to come out to be 150. And then 150 divided by 5 is 30. So then our second thing that we're going to do is find all of our differences. So second, find the differences, and basically we're just going to be subtracting this mean with all 5 of the numbers that are listed in the most expensive dishes. So we'll go ahead and start with 28. We always want to subtract to get a positive number. You're basically finding the absolute value of your distance. So we're going to do 30 minus 28, which is 2. Then we have 30 minus 30 to get 0. Next, you're going to do another 30 minus 28, which is 2. And then this time we'll put 30 on the bottom because we want a positive number. So 39 minus 30 is 9. And finally, 30 minus 25 is 5. Now, obviously, you probably don't need to actually write out those subtraction problems, but I just want to be really, really clear about where these numbers are coming from. Okay, and then for the third part, we're going to go ahead and find the mean of all the numbers in part 2. So we'll find another mean. So this time we'll use 5 numbers from part 2, 2 plus 0, plus 2, plus 9, plus 5, all divided by 5. So when you add up your numerator, you're going to get a total of 18. And 18 divided by 5 is 3 6/10. So the mean absolute deviation for the first set of numbers is 3 6/10. That means on average, each of these prices are about $3.60 away from the mean of 30. All right, now let's look at our 5 least expensive dishes. We're going to go through those same steps just with different numbers. So just like before, I'm going to go ahead and start off with finding the mean. So we can add up 7 plus 7 plus 10 plus 8 plus 12, and then whatever we get, divide that by 5. So this time the numerator adds up to 44, and 44 divided by 5 is 8 and 8 tenths. So $8.80 is the average price of all of those dishes. So then for step 2, we'll go ahead and find our differences again. We'll just subtract. So since I've got a decimal or a number in the tenths place, it's going to be especially important to be sure that I'm lining up my decimal points. So when I start with $8.80, I'm going to subtract 7, and again, line up your decimal point to be sure that you've got the right value. So that's going to be 1 and 8 tenths. We have another value of 7, so same thing for our second number. Then our third number, we're going to put 10 on top since it's larger, and subtract 8.8 from that to get 1 and 2 tenths. Then we're going to subtract 8.8 minus 8 to get 8 tenths, and then finally 12 minus 8.8 to get 3 and 2 tenths. So important part on that is just making sure decimals are lined up, and then we're going to go ahead and find the mean of those numbers. So all right, step 3 is another mean, and you don't necessarily need to label each one mean, difference, mean, but again, I just want you to be able to see exactly where all these numbers are coming from. Okay, so part 3, we're going to find the sum of the 5 numbers in step 2. So we'll add all of those up, and then whatever we get, we're going to divide by 5. So the sum of those numbers comes out to 8 and 8 tenths, and 8.8 divided by 5 is 1 and 76 hundredths. So right here, this is going to be the mean absolute deviation for the least expensive dishes. That means that on average, the dishes are about $1.76 away from the average, which was $8.80. Okay, now we're going to go ahead and write a comparison about which one has more variation. So just remember that mean absolute deviation shows you how much the numbers vary from each other. A higher mean absolute deviation means that there's more variance. A lower mean absolute deviation means there's less variance, so the numbers are grouped a little bit more closely. Okay, so for my comparison, remember the more expensive, so I'll do maybe more expensive, that was 3 and 6 tenths, and then the least expensive was 1 and 76 hundredths. So we're going to go ahead and use those values to write a comparison between those two things. All right, so an example of what you could write for your comparison, I said the more expensive dishes have more variation within their prices. I know this because a mean absolute deviation of 3 and 6 tenths is greater than a mean absolute deviation of 1 and 76 hundredths. So that concludes mean absolute deviation notes. Remember 3 things you're going to do: find the mean, subtract to find all of your distances, and then find the mean of all of your new numbers. So none of this is super complicated math. It's just a matter of being really organized and taking your time and making sure that you don't make a mistake that will throw everything else off. And then once again, mean absolute deviation is just a way to measure how spread out the numbers are, and it's going to be your average distance between each data value and the mean. All right, thank you for watching, and good luck with your computations.